The functions f and g are defined with their respective domains by f of x is equal to x squared for all real values of x, and g of x is equal to 1 over 2x plus 1 for all real values of x, where x doesn't equal minus 0.5. Explain why f does not have an inverse. The inverse of g is g minus 1. Find g minus 1 of x, state the range of g minus 1, and solve the equation f of g of x equals g of x. So I've written down the question in summary form then, here. So the first one is explain why f does not have an inverse. Part A. Well, here, if we draw the sketch, just a little sketch of f of x is equal to x squared when x belongs to R. It's not 1 to 1, is it? So for any y value, there will exist more than one x value here, for example. So f is not 1 to 1, so does not have an inverse. Okay, part B, the inverse of g is g minus 1. Find g minus 1 of x. So B, y is equal to 1 over 2x plus 1, isn't it? So put a bracket around it because we're going to move it. Move that up to the top on the other side. And at the same time, leave the 1 as is, but move the y down underneath on this side. Then move the 1 over. So we get 2x is equal to 1 over y minus 1. And then move the 2 from times to divide. Effectively divide by 2 through the entire equation, basically. So y is equal to 1 over 2y, divide that by 2, minus a half when 1 is divided by 2. So we can now write g to the minus 1 then of x is equal to, now just swap the y's to x's, that should be an x, shouldn't it? Swap the y's to x's and the x to y's. So that's what we've got there. So this function then is 1 over 2x minus a half. So there's the inverse function then. And it's defined on the range of g, and the range of g, if we could get that, but I don't think it's asking us for that. It's just the inverse function, find g minus 1. State the range of g minus 1 then, which is going to be, the range of g minus 1 is the domain of g. So what is the domain of g? So let's write that down. So range of g minus 1 then is equal to the domain of g, which is equal to all x except x equals minus 0.5, all the real number line, except that x doesn't equal minus a half. So there's the range then. So that's part C. Now part D, solve f g of x equals g of x. So let's have a look at this then. F of g of x, so it's f of g of x is equal to f of, now g of x is 1 over 2x plus 1. And f is send something to something squared, doesn't it? So this is 1 over this, the whole thing squared is the top squared, which is 1 over the 2x plus 1 squared. And that's going to equal then, in part D, g of x, and g of x is 1 over 2x plus 1. Okay, so solve this then. Well, okay, so this implies then, so we've got a 1 over 2x plus 1 out, 2x plus 1 outside a bracket, and inside the bracket we're going to have another one of them. And then this is moved over. I've moved this over and taken out a 1 over 2x minus 1, so there's a minus 1 here, equals 0. So just check that, expand the bracket, 1 over this squared, minus the 1 over 2x plus 1, which we moved over. So we get that. Now this thing here, this doesn't equal 0, does it, for any value of x? so this is always going to be non-zero. For x very, very large, it gets close to 0, but it never actually equals 0. And large negative as well, for that matter. But this one will equal 0, so it implies 1 over 2x plus 1. When does that equal 1? Move the 2x plus 1 up then, to times 2x plus 1 is equal to, and I'm reading it from right to left, it will equal 1. So 2x is equal to, move the 1 over, we get 0. So x equals 0 is the value that we get when we solve that equation. So that was part D.